Hello and welcome to this Promathematica for Competitive Exams channel. My name is Gracie and I've been teaching mathematics and Java since the early 2010s. We're going to start the discussion about competitive exams a little differently than you may be expecting. This module elaborates the problems and solutions for aptitude test and its comprehensive demonstration through Java programming. Why would I want to use Java? Well, here's a peek ahead at the answer. Because we'll be able to develop easily. A competitive examination is an examination where candidates are ranked according to their grades and/or percentile, and then top rankers are selected. Competitive examinations are considered an egalitarian way to select worthy applicants without risking influence peddling, bias, or other concerns. Early exposure to learning and competition builds confidence and sharpens skills, which raise your level from other students on the same platform. Competitive exams also help out in choosing a career as students start identifying their areas of interest while getting a deeper knowledge of subjects. Top business schools based in North America, Europe, Asia, and Australia conduct this exam. Several leading corporations also conduct such tests for assessing potential candidates' quantitative reasoning skills. Today, I am going to cover a very important topic. It is alligation and mixture. I am going to represent several problems and solutions based around this topic. I will be writing code for the solutions using Java. So, let's get started without further delay. In what ratio water must be mixed with milk costing $48 per liter to get a mixture worth $32 per liter? Here is an answer with explanation. Cost price of water is $0 and cost price of 1 liter of milk is $48. And mean price equals $32. By using the mean price, we further get the revised water price and revised cost price off 1 liter of milk respectively. So, water to milk ratio would be 16 to 32 is equal to 1 to 2. A shopkeeper mixes 60 kilograms of sugar worth $30 per kg with 90 kilograms of sugar worth $40 per kg. At what rate he must sell the mixture to gain 20%? Here is an answer with explanation. Total cost price of 60 plus 90 equals 150 kilograms of mixture equals 60 times 30 plus 90 times 40 equals $5,400. Cost price per kg of mixture equals 5,400 divided by 150 equals $36 per kg. Now, required gain equals 20%. Therefore, required selling price per kg of mixture equals 120 by 100 multiplied by 36 equals $43.20 per kg. 700 milliliters of a mixture contains water and milk in the ratio 2:8. How much water must be added to the mixture so that the ratio of water and milk becomes 3:8? Here is an answer with explanation. Milk in the 700 milliliters of mixture equals 700 multiplied by 8 divided by 10 equals 560 milliliters. So, water in the mixture would be equals 700 minus 560 is equal to 140 milliliter. Let water to be added equals X milliliter. Now, 140 plus X divided by 560 is equal to 3/8. Next, 1120 plus 8x equals 1680. Therefore, x equals 560 divided by 8 is equal to 70 milliliter. Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. Programmers write once, run anywhere, meaning that compiled Java code can run on all platforms that support Java without the need for recompilation. The JDK is a development environment for building applications using the Java programming language. The JDK 12.0.2_Windows x64_bin exe includes tools useful for developing and testing programs written in the Java and running on the Java platform. In addition, the Spring Tool Suite, STS, provides the best Eclipse-powered development environment for building Spring-powered enterprise applications. STS supplies tools for all of the latest enterprise Java and Spring and comes on top of the latest Eclipse releases. STS supports application targeting to local, virtual, and cloud-based servers. It is freely available for development and internal business operations use with no time limits. Here is the problem statement. I am going to define a new method for determining the water-to-milk ratio for earlier solved problem 1. I have used the scanner class's object for reading the input values from the console. Next, nextInt method reads the integer values one by one from the console. I have closed the scanner object by calling close method to avoid excessive memory usages and to improve application's performance. Next, define the cost price of water to 0. Next, revised water price is calculated as mixture quantity minus cost price of water. Next, the revised cost price of 1 liter of milk is calculated as milk costing price minus mixture quantity. Next, water-to-milk ratio is calculated as revised cost price off 1 liter of milk by revised water price. The last step is to return the water-to-milk ratio. Here, I am printing the water-to-milk ratio by calling Alligation Mixture method. Execute the code by right-clicking on the Java class. Here is the result on console. Here is the problem statement. I am going to define a new method for determining the required selling price for earlier solved problem 2. I have used the scanner class's object for reading the input values from the console. Next int method reads the integer values one by one from the console. I have closed the scanner object by calling close method to avoid excessive memory usages and to improve application's performance. Next, the cost price of sugar 1 is the product of sugar quantity 1 and sugar 1 rate. Similarly, the cost price of sugar 2 is the product of sugar quantity 2 and sugar 2 rate. Then, the total cost price is the sum of cost price of sugar 1 and 2. Next, the total sugar quantity is the sum of sugar quantity 1 and sugar quantity 2. Next, cost price per kg of mixture is calculated as total cost price divided by total sugar quantity. Next, the required selling price is calculated as 100 plus gain percentage by 100 times cost price per kg of mixture. The last step is to return the required selling price. Here, I am printing the required selling price by calling alligation mixture method. Execute the code by right-clicking on the Java class. Here is the result on console. Here is the problem statement. I am going to define a new method for determining the water quantity for earlier solved problem 3. I have used the scanner class's object for reading the input values from the console. Next int method reads the integer values one by one from the console. I have closed the scanner object by calling close method to avoid excessive memory usages and to improve application's performance. Next, the sum of numerator and denominator is the sum of ratio 1 numerator and ratio 1 denominator. Next, the milk quantity is calculated as the mixture divided by sum of numerator and denominator multiplied by ratio 1 denominator. Next, water quantity in mixture equals mixture minus milk quantity. Next, let water to be added equals x milliliter. Now 140 plus x divided by 560 is equal to 3 by 8. So, the water quantity equals 560 divided by ratio 2 denominator. The last step is to return the water quantity. Here, I am printing the water quantity by calling alligation mixture method. Execute the code by right-clicking on the Java class. Here is the result on console. Hope you liked this video. In order to see new videos, don't forget to subscribe to Promathematica channel.